record, and here we go. So real quick, the previous problem that we looked at was an object thrown upward from the top of an 80-foot building. And notice that the arc, or the projectile motion that this object has, is a parabola. So we know this is a quadratic. In fact, the equation given to us, h equals negative 16t squared plus 64t plus 80, is quadratic. So everything that we've studied, it's all fitting the mold, okay? So they asked, when will the object hit the ground? So what I did is I drew like a little XY thing just to show you. I said XY thing, what a dummy. XY grid, okay, or axes. And what I wanted to show you was the moment that this object hits the ground is the same thing as saying the x-intercept, okay? Because if I and I'm going to label these properly now, that the horizontal axis will be t for time, and the y-axis will be h for height. So when the height is 0, which that's an x-intercept, you can actually figure this out. So what do? We take the quadratic, we set it equal to 0, we factor, we set each one of the factors containing a variable equal to 0, and we solve. We're going to do the same exact thing with this problem right here. So a hang glider pilot accidentally drops her compass from the top of a 400-foot cliff. Okay? The height h, so that's important, of the compass after t seconds, that's important, is given by the quadratic equation h equals negative 16t squared plus 400. When will the compass hit the ground? So the first thing I'm going to do, all right, here we go. So there's my person hang gliding, to scale, perfectly drawn. And they're standing on a 400-foot cliff. So they're just about to jump off. And what happens is the compass that's in her hand will fall down. Okay? And it follows this parabolic trajectory. All right? Unless you literally dropped it straight down. But that's not what the problem said. All right? So we know the following. I can assume that I could kind of draw these axes. I know when the compass hits the ground. In this case, that'll be the t-intercept, only because the variable is t. So I'm going to take my equation, and I'm going to set it equal to 0. So solving this problem still follows all the steps that we've learned, I think, the last like two classes. So we set it equal to 0. All right. Now, step 2 is we factor. Hopefully by now you have the factoring flowchart printed up, and you're looking at it, and you look at it every single problem. Hold on a sec. He's biting a wire. Hey, no wire. No wire. No wire. Get squirrely. There you go. Sorry about that. So we set it equal to 0. You got your flow chart. Step 1. Is there a GCF? You guys got to tell me yes or no. Is there a GCF? I love it. So we factor out a negative 16. That's going to give me t squared, and I think last time I checked, 400 divided by 16 is going to be 25. So far, so good, everybody? Yes or no? All right. So 0 equals negative 16 times the quantity t squared plus 25. Now, I ask myself, inside the parentheses, can that be factored? So my polynomial type is a binomial. The t is squared, so I'm thinking difference of squares, hopefully. And I got a minus sign. So what's that factor down into? Notice you didn't have to do any work. All you do is just follow a flow chart. What's it factor down into?
T plus 5, T minus 5.
Love it. You okay there, Jay?
In my throat.
So now I set each one of these factors equal to 0. So the first one I solve by subtracting 5 from both sides of my equation. The second one I solve by adding 5 to both sides of my equation. Now, mathematically, this is correct. I get 2 answers mathematically. But in this application, only one solution is valid. Which one is it?
5.
Why?
Because you can't have negative seconds.
I agree. April, if you could figure out how to go back in time, I will give you anything you want. Because I'd love to go back in time. Courtney, if you can go back in time to one age, what would it be?
Probably 19.
19?
Yes.
Unpopular opinion, I'd redo high school.
Well, you know what? Actually, I'm with you there.
I absolutely loved high school. Loved it. I loved waking up every day and going to school. Anybody else like me, or are you the exact opposite? You hated high school.
Opposite. My daughter loves school, but I failed a lot of classes in high school.
So you're thinking about it in terms of going back and doing it right.
Yeah.
I'm thinking about it as going back and just hanging out with my friends. Having a good time.
I did that all the time.
Yeah, me too. It was fun.
I failed classes.
Eunice, what about you? Would you go back to high school if you had the chance?
I go way back to like middle school
Wow.
and taking the knowledge, like if only with one exception, if I took the knowledge I have right now back to time.
That would be ideal. That would definitely be ideal. If I could take what I've learned up into my life right now and go back into high school, I'd dominate. It would be awesome.
Yeah, you just basically have I don't know, you'd just be walking around doing tests, getting them right, then just sitting in class doing nothing, having the time of your life outside.
Yep. So I would definitely redo high school. But that's just me. All right, next problem. So this is just a standard, word problem. Nothing special about this. The sum of a number and its square is 182. Find the numbers. So when you approach a problem like this, where there's no story or anything behind it, it's just the way I think about this is just a boring problem. First thing I'm going to do is find the equal sign and put an equal sign. Anything to the right, I'm going to label. Now, anything to the left, I got to figure that out. The sum of a number and its square. So I don't know what the number is. So I'm going to let x equal a number. Okay? Now, how would I write the sum of a number and its square? How would I write that? That's only one of the terms, Abigail, but you're correct. So I'll write x squared. I want the sum of a number and its square. Can you help me out? You gave me this right here. Well, you got a sum. So I need to add something else. Do I not? I mean, you can't take the sum of one number. It has to be at least two. What are the two numbers? The sum of a number and its square. So what's the other number? What goes right here?
X.
Perfect. So notice it's quadratic. So I'm going to try my steps. Step 1, set it equal to 0. To do that, I need to subtract 182 from both sides. All right, step 2, factor time. There is no GCF. My polynomial type is a trinomial with 3 terms. And a 1 is up front, so that's good. So I can go directly into this. Now, let's fill in our signs and the x's. I need a plus and I need a minus. Okay. Now I got to find the factors of 182. All right, and there's a bunch. There is. So let me write them out. I'm going to go to 15. And anytime you're approached with something like this, honestly, to save yourself hassle, to save yourself some time, just get out a calculator. All right? I know 1 times 182 is 182. And then, like I said, to save yourself some time, just take 182 and start dividing it by numbers. So 2 and 91. 182, what's that? 9 and 2. That doesn't work. 3 doesn't work. Or does it? No, I don't think it works. No. 4, I don't think works. Oh, yeah, 4 does work. It's 91. How about that?
You put 2, not 4.
I what?
You did 182.
Oh, I did, didn't I? No, 4 doesn't work. Thank you. Who corrected me on that, Carly?
That's Abby.
Abby, thank you so much for that. Yep, so this is all I'm doing, is just taking 182 divided by every single number. All right. So far, nothing good. And what I mean... Oh, syntax. What I mean by nothing good is I have not found any numbers that combine to give me positive 1 yet. 10 definitely doesn't work. 11 doesn't work. I know that. I'm going to try it anyways. What just happened? Yep. 182 divided by 12. Nope. 182 divided by 13. Perfect. Because now if I take 182 divided by 14, I get 13 back. So I don't need the rest of these numbers down here. And also, I'm very excited because I know one of the numbers is positive, the other number is negative, and if I want to combine them to give me positive 1, that occurs right there. Negative 13 plus 14. So negative 13 plus 14. Now, I said each one of these factors equal to 0. And I solve appropriately. So for my first solution, x equals negative 14. Then I add 13 to both sides. For my second solution, x equals positive 13. Okay? How are we looking so far, everyone? Pretty good? This is just your standard. Just set it up, solve. All right. One more problem. This is my favorite one. Well, another favorite. I like falling body problems, and I like ladder problems. So here we go. A ladder is leaning up against a building so that the distance from the ground to the top of the ladder is 1 foot less than the length of the ladder. Find the length of the ladder if the distance from the bottom of the ladder is 5 feet. All right, so let's go ahead. Let's start labeling some things. First, we have that distance right there. They told us from the bottom of the ladder to the wall is 5 feet. Can you still see that? Can everybody see that on their screen? Because I'm using yellow. Okay, good. The second thing they told us was that the ladder itself is X, and the distance from the bottom of the ladder, from the bottom of the wall to the top of the ladder is 1 foot less, so X minus 1. So they kind of hooked us up here. Now, from here, you got some formulas you got to be concerned with. And we know some of them. For example, A equals 1/2 base times height. That's the area of a triangle. But they didn't ask for the area of the triangle, did they? They didn't ask for the area of the ladder. They wanted the length of the ladder, correct? So this, not a good formula. Okay? We know the perimeter. All you would have to do is just add up the sides, right? But that's not going to help us here because we don't know the actual length other than the bottom of the ladder to the wall. Like, that's the only one we know. The question becomes this. Are there any other formulas that you remember or that you know of that can help us with this? I mean, there is one that you would have learned in MAT090. You would have learned it all the way at the end of the semester. It would have been section 7.3. To be honest with you, this is the formula. Anytime you see a triangle, this is the one you should be thinking of every single time. Let me be more specific. I'm sorry, I misspoke. If you see a right triangle, I'm pretty sure if I wrote down one or two of the terms, you could finish it for me. Can anybody finish it? A squared plus?
B squared equals C squared.
And what's that called? What formula is this? You're correct. What's the name of the formula? Starts with a P. There you go. This is called the Pythagorean theorem. And what it does is it relates the legs to the hypotenuse of a right triangle. Now, the hypotenuse is always the longest side opposite of the right angle. Okay? So, if I'm looking at my right triangle here, oops, wrong color. If I'm looking at my right triangle, that is how I would label it. The longest side opposite the right angle, right here's the right angle. That is going to be C. And then the other two sides, it doesn't matter what you label them because they're just the legs. So A and B. All right? Are there any questions so far? Okay, now here's what's nice. They told us everything, or better yet, let me say it this way. They told us the lengths of each one of these sides of the triangle. They said the base is 5 feet. The distance from the bottom of the wall to the top of the ladder is X minus 1. And then they said the ladder itself is X. So what we need to do is make our substitutions. And remember, anytime we make substitutions, we always put them in parentheses. So I'm going to go ahead and make these substitutions here. Oh, Mike, give me that marker. All right, here we go. So 5 squared plus x minus 1 squared equals x squared. Are there any questions with what I did? All right. I'm going to let you solve this. So go ahead and solve this for me. Anybody get an answer yet? I'll give you a hint. It should be a nice whole number answer. Shouldn't be a decimal or a fraction or anything like that. Anybody with an answer yet? April, what'd you get?
I got 13 feet.
13 feet. Does that sound like a good answer for the length of a ladder? What do you think? I mean, how tall are you?
How tall am I?
Yeah.
Like about 5'3" or something.
5 foot, your average height then. Okay, so you're 5'3".
Kind of a shorty, but
No. Average height is about 5'4". Okay. So let me ask you a question. 13 feet, if you thought about yourself, you're 5'3" and you double it, that's like 10 feet. Does that sound like a good distance for a ladder? I mean, isn't a ladder supposed to get you to higher elevations, right? So does your answer make sense?
Probably not.
What do you mean?
Okay. Okay.
April, if you came up with 1,300 feet,
Well, yeah.
you're going to climb to the top of the U.S. Steel building. 13 feet sounds good. Anybody else get 13? I'm not saying it's correct, but got to be honest with you. When I use common sense, I'm like, 13 feet sounds pretty good for a ladder. I mean, I don't think you have a lot of experience buying ladders. I mean, not... yeah, have you ever gone to the store to buy a ladder?
No.
No. They sell ladders in like 6 foot, 8 foot, 10 foot, 13 feet, and I think like 25-foot ladder and a 40-foot ladder. I don't like 40-foot ladders because I don't like heights. But every couple of years I paint the outside of my house and I have to get a 40-foot ladder and I hate it. How many of us are stumped? Yeah, I think April's right. I think the answer is 13. Let's see why. First things first, we're going to go left to right. 5 to the second power is 25. X minus 1 quantity squared is x squared minus 2x plus 1. How did he get x squared minus 2x plus 1 there? And on the right-hand side, it's just x to the second. Now, if you made a mistake, it's probably right here. Because hopefully you didn't break my heart. Hopefully you remembered that, and I'm going to go off to the right here. X minus 1 quantity squared means x minus 1 times x minus 1, and you have to actually distribute that. So you're going to get x squared minus x plus 1, which is x squared minus 2x plus 1. If you wrote x squared minus 1 or x squared plus 1, you broke my heart on a Friday. So, let's finish now. I see the x squared term. See, that's the dominating term. You should always be looking for the highest degree. And that's going to tell you your technique. So I see x squared. I see one right here. And I see one right here. So I'm going to get this together. In fact, since I see the x squared, I'm going to set the equation equal to 0. That's my first goal. So what I'm going to do is I'm going to subtract x squared from both sides. And just to be more specific so you know which one I'm moving, I'm going to move the one highlighted in yellow. So I subtract x squared from both sides of my equation. And I get 25 minus 2x plus 1 equals 0. And then I go to myself, uh-oh. My x squared term actually canceled itself out. Well, guess what, April? It happens. As long as your math is correct, you have nothing to worry about. Stop second guessing yourself so much. You know you got to get them together, and you got to set the equation equal to 0. If it cancels itself out in that process, then that's what it does. So now I look on the left-hand side. That x is raised to the first power. This thing is linear. So I look on the left. Can I group any like terms? The answer is yes. 25 plus 1 is 26 equals 0. I get the variable terms on one side, constant terms on the opposite side. So I will subtract 26 from both sides. Now I would divide both sides by the number in front of the variable. A negative divided by a negative is a positive. 26 divided by 2 is 13. So the length of the ladder, which I'm going to redraw the picture directly below. The length of the ladder is 13 feet. The distance from the bottom of the wall to the top of the ladder is 13 minus 1, or 12 feet. And the distance from the bottom of the wall to the bottom of the ladder, it was given, is 5 feet. Are there any questions? April, good job. I'm going to give you a thumbs up because I like thumbs up. I think it's a cool thing to do. Like back in the 80s, they were like, thumbs up. So I'm bringing it back. So are there any questions? I don't know if there's a problem like this on a test. I can't remember. But if there is, use this as your model. And you got to just think about every little step. Okay?